Right. Trig lecture 215, 216. Student will solve trigonometric equations restricting values of theta such that 0 is going to be less than or equal to theta, which is going to be less than 360 degrees. In other words, we're going to just limit theta to one trip around the circle, so to speak. Okay? So hopefully that will make sense when we start working. You'll see what I'm talking about. Quadrantal angles. If we run into an angle that's quadrantal, we're going to use the unit circle. This says quadrantal angles are angles in standard position. That means that the positive x-axis is the initial side and the terminal side is wherever the rotation stops. And if it has the terminal side on one of the axes, if it stops on the y-axis, or if it rotates and stops on the x-axis, or if it rotates and stops on the negative y-axis, those are quadrantal angles. Then we're going to use the unit circle and this triangle right here, where horizontal is x, vertical is y, and we'll call this R. And I'll show you how to use that to solve our problems that we're going to be doing today if we have a quadrantal angle, if the rotation stops on an axis. So let's take a look here what we're messing with. Solve for theta, we're just going to use our calculator and the inverse trig functions, and then use our head. The ASTC, all students take calculus. We're going to be looking for more than one angle potentially. So here we go. I want to solve this for theta. So what I'm going to do first is divide both sides by -2, and then I'll have sine theta is equal to whatever that is positive radical 3 over 2. Then take the inverse sine of both sides and I'll have one angle, and then I'm going to use all students take calculus and determine if there's another angle that works. So here we go. Let's see if this makes sense for you. I'm going to divide both sides by -2. This gives me positive, because negative over negative, positive radical 3 over 2 is equal to the sine of theta. Now theta is limited to between 0 and 360 degrees. So I'm asking myself here, I know that sine is positive. Where is sine positive? Well, sine is positive in quadrant 1, and sine is positive in quadrant 2. So whatever I find here with my calculator, I'm going to find a reference angle in quadrant 2 that has the same value. So let's take a look here. We're going to say the inverse sine of theta, because that's what theta will equal to, the inverse sine of radical 3 over 2. And make sure you put that in parentheses with your calculator. And this will give us a value of theta that will make this equation true. And then, but there are two possible values. You'll see here in just a second, I hope. Shift, inverse sine, parenthesis, square root of 3 over or divided by 2, close parenthesis, equal. I just took the inverse sine of that with my calculator and it says 60 degrees. Okay, so I know that 60 degrees is one of my angles. Where else is sine positive? Well, it's in quadrant 2. In quadrant 2, sine is positive. So I'm thinking, well, if I have a quadrant 2 angle that has a 60 degree reference angle, what would this angle be? I'm in quadrant 2 with a 60 degree reference angle, and that would be 120. So 60 or 120 are the two values I'm looking for, unless I've made a mistake. And I've made lots of mistakes in my life, and I may have made a mistake right there, but let's hope I didn't. Let's take a look and see. Got a key around here somewhere. 60 or 120. I'm going to highlight these real quick. I highlighted in Algebra 2, I highlighted the answer key, highlighted one of the wrong answers. Why I did that, we may never know. Okay, so that's basically what we're doing. The calculator gave us one answer. We said, where else is sine positive? We found a reference angle. Use this as a reference angle to find the other angle. Okay, let's take a look at this one. We're going to add 5 to both sides. That gives us the tangent of theta is equal to 0. So we're going to do the same thing. The inverse tangent, we're going to take the inverse tangent of both sides of 0 will be equal to theta. Whoops, I said theta. And let's see what the calculator tells us. Second function, tangent, 0 equals, it says 0 degrees. So theta is 0 degrees. I want to know where else could tangent possibly be 0 degrees, and I can't use all students take calculus because 0 is neither positive nor negative. So here's what we're going to do. We're going to use the unit circle and this little triangle and see where else tangent is equal to 0. Here's that little triangle. I'll bring it down here. This horizontal is x, vertical is y, just like the axes. And we'll call this r and put theta right here. We set it up like that. And with a unit circle, we've got a circle that is 1 unit in radius, the radius of which is 1 unit. So from here to here is 1 unit, from here to here is 1 unit. The radius of this circle is 1 unit. 0 degrees is right here. The initial side is the positive x-axis, and it doesn't rotate at all. It rotates 0 degrees, so the terminal side is right there. In other words, it's a ray. I want to know where else might that happen in the unit circle where we have a quadrantal angle. So what I'm going to do is I'm going to say, well, if this is a unit circle and the radius is 1, the coordinates of this point right here are over 1 up 0. That's an x value and a y value. And the radius is 1. That's the definition of a unit circle. If I rotate 90 degrees, that's a quadrantal angle. That would put me right here on the unit circle. That particular point is over 0, up 1. So I have an x value of 0, a y value of 1. And again, my radius is 1 because that's the definition of a unit circle. The radius is 1 unit from here to here. When we come and look at this one, this quadrantal angle, if I rotate 180 degrees, I'll be right here. The coordinates of this point are -1, 0. That's an x value of -1, y value of 0. And again, r, from here to here, r has a value of 1. The radius is 1 unit long. And if we rotate 270 degrees, initial side here, and then rotate and stop on the axis, that's a quadrantal angle. If we stop right there, the x value will be over 0, down 1, over 0, down 1, that's the coordinates of that point. And that would be an x value and a y value. And again, r is 1. What we're going to do is ask ourselves, since we're dealing with the tangent function, and we got tangent, we got theta is equal to 0 degrees, and we're messing with the tangent function, we want to know where else could tangent be 0. So I'm going to find the definition of tangent in terms of x, y, and r using this triangle. I'm going to say the tangent of theta is equal to opposite over adjacent, y over x. And then I'm going to go around this unit circle that I just described here and find where y over x equals 0, and I'm going to make sure that I only go around once. I'm limited to be going between 0 and 360. 360 is not included. Got to be less than 360. So here we go. I'm going y over x because I'm looking for tangent, which is by definition in this particular triangle y over x. So I'm going to go y over x. Y over x at 0 is 0, which is what we expected. We got that with our calculator. Y over x here is 1 over 0. That's undefined. You cannot have the 0 in the denominator. That's undefined and it's not equal to 0. So our other angle isn't 90. What's y over x here? Well, that's 0 over -1. 0 divided by anything other than 0 is 0. So this is 180-degree rotation. So this could be 180 degrees also. Scooch this over to the left a little bit so it's not quite so crowded. There we go. And if we go at 270 degrees, we rotate 90, 180, 270. This is the initial side. We stop here. Y over x would be negative 1 over 0, which is undefined. You can't divide by 0. And we can't go back to 360 because we're limited to one trip around the circle, 360 degrees of rotation, not counting 360. Start at 0, stop just before 360. So these are our two angles, such that if I take the tangent of 0 and then subtract 5, I'll get negative 5. If I take the tangent of, what did I say, 180, I'll also get, that'll make that equation true also. So there we go. We're using this little XYR triangle and the unit circle if we get a quadrantal angle. Let's see if we got that right, if I got it right. That's what they said, 0, 180, yay! I was afraid I might have messed that up. So let's take another look at another one. I know that seems confusing at first, but after you've done it a time or two, it's pretty simple. Unit circle is just a circle that has a radius of 1. The center of the circle is at the origin. So you go over 1, up 0, over 0, up 1, over 1 to the left is negative 1, up 0, and over 0, down 1 for your quadrantal angles. Those are angles that stop on the axes. We'll do them in class if you have any questions. Let me get this out of our way here. Probably won't be lucky enough to move that whole thing, but I'll try. Hey, it moved, what do you know? Okay, let's take a look at this one. I want to divide both sides by negative 8 to get sine. This is negative 1/2, so I'm going to reduce that fraction. Negative 1/2 is equal to the sine of theta. So I'm going to say theta is equal to the inverse sine of negative 1/2. Make sure you use parentheses. Whenever you take the inverse sine of something that's a fraction, make sure you use parentheses. Okay, let's see what we get. We may get a negative angle here. If we do, we're still restricted to positive angles between 0 and 360. So we'll have to use a coterminal angle. You'll see here in just a second, if this indeed turns out to be negative. I'm going to hit second function or shift. Yours might say shift up there. Sine, negative 1. Negative 1 over 2, close parentheses, equals. Yep, it does. It gives me negative 30 degrees. So I want, here's the thinking that I'm doing. Here's negative 30 degrees, roughly. But I want positive values of theta, not negative 30. So what I want is the coterminal angle, which that's pretty simple. That would be 30 degrees shy of a full rotation would be 330 degrees. So theta would be 330. And I'm getting sine as a negative value. Where else is the sine negative? Well, the sine is positive in quadrant 1. The sine is positive in quadrant 2. So I'm in a quadrant 3 also with a, excuse me, a reference angle of 30 degrees. So if I draw a reference angle in quadrant 3 that's 30 degrees, I want to know what is this rotation also. Oops, hit my 30. Dang it. Hopefully you can tell that's 30. That'd be 180 plus 30 would be 210. So those are the two angles such that if I take the sine of them, I'll get negative 1/2. Okay. We've done reference angles and coterminal angles and all that sort of stuff, so hopefully that makes sense. Messed up my little drawing here, dagnabbit. Okay, let's take a look at one more. Oh, let me check my answer, make sure I didn't botch it. 210 degrees and 330 degrees. Yay! This is a false statement. That should say or, not equals. Let's see if I did that on any of the others. Or, yay. Okay. Let's do one more here. I'm going to add 1 to both sides, and I'll have 1 minus 1/2 is 1/2. Cosine theta is 1/2. So I'm going to say, well, the inverse cosine of 1/2 with my calculator. Make sure you put it in parentheses with your calculator. Will be equal to theta. Let's see what we get there. Second function, or shift, it might say shift. Whoops. Shift, inverse cosine, hit the wrong button. 1 divided by 2, or you could just put in 0.5, equals, that gives me 60 degrees. So that's one of my angles. The cosine is a positive value. Well, where else is cosine positive? All students take calculus. So the C stands for cosine, so quadrant 4. So if I have a quadrant 4 reference angle of 60 degrees, what's this rotation going to be? Well, that's 60 degrees shy of a full circle, so that'd be 300 degrees. So 60 degrees or 300 degrees would make that equation true within the limits that our instructions set, between 0 and 360 degrees. So hopefully that makes sense. We've done something very similar to this in the past. You can think of this as a little review. Sometimes I think on the answer key, it's giving your answers in set notation, like this would be 60 degrees, comma 300 in set notation. That's fine. That's as good a way as this. One was correct. Now let's see if I got it right. 300 degrees or 60 degrees, yay! So there we go. Solving trigonometric equations restricting values of theta that are between 0 and 360 degrees. 360 is not included, 0 is included. Okay, so there we go. Pretty simple, straightforward stuff. We'll talk more about the unit circle before the end of the year. This is like a little introduction. You can do this.